All right, here's the next one. This is based on a student request. We're going to solve this system of equations. This came from the section using substitution. So that's the method that I am going to use to solve this system. So if I'm going to substitute anything, the first thing I need to do is get something that x equals or y equals first. So I need to isolate either an x or y in either of the equations. And I notice right away in this first equation that if I add 7y to both sides of the equal sign, that I'll have x equals something. So that's what I'm going to do there. So I've rewritten the equation to the right there just so I have a little bit more room, and now I'm going to add 7y to both sides like this. I could change this to a type of slope-intercept form if I wanted to, but I don't have to. I just can write this as x equals 15 plus 7y. Now I have something to replace an x with in what I would have to use as the second equation. Since this purple equation here came from the first equation, the top equation, I have to replace the x in this bottom one. Otherwise, I just get 0 equals 0 in that top equation. Some of you guys may have found that out already, and this is why, and that's why that happens there. So let's go ahead and write this equation, but I'm going to replace the x with this 15 plus 7y. I'll use the color there. All right, now that I have it this far, you can see we had negative 5x minus 2y equals 36. Next thing I'm going to want to do here is to distribute that negative 5, which gives me this new equation, negative 75 minus 35y minus 2y equals 36. And I'll combine the like terms there. So negative 35y and negative 2y. Now I'll go ahead and add 75 to both sides. So I have negative 37y equals 111. Finally, to solve for y, I'll have to divide both sides by negative 37, which gives me that y is a negative 3. So that's our first part of the answer, which I will write at the top. So you can see there my y value is negative 3. I'm going to write this as an ordered pair or coordinate pair. Next thing I need to do is to solve for x. Now some of you guys use the equations that you derive. So maybe you used this purple equation here to solve for x. I don't recommend doing that just because if we've done something wrong in this part of the problem, it may throw us off with our answer. Okay, so let's go ahead and use the top equation there to solve for x. So there's my equation, but instead of y, I have a negative 3. And when I multiply these two, I get a 21 positive. So I have x plus 21 equals 15. Finally, to solve for that x, I'll subtract 21 from both sides. And that tells me that x is negative 6. So I'll replace the x with negative 6 there in the coordinate pair. But please don't forget, all right, you guys, I'm not going to do it because of time purposes. I know this is boring enough as it is. But please don't forget to check your answers, okay? You would use the two original equations. You would replace the x's with negative 6 and the y with negative 3 just to make sure it's correct. Now, I've done that already, but I'm not going to take the time to do it on the video, again, just because of time purposes, okay? So I hope this video has been helpful. I hope that it helps you to see how to use this substitution even though both of the equations are in standard form. Now we've already learned elimination, which would help us in this manner, but just in case it didn't, I hope that this one has. So good luck on your math, good luck on the homework, and thanks for watching this video, you guys.